So there's your learning goal. I can convert rational. Rational means it can be written as a fraction, so we'll be working with fractions. Rational exponents to radicals to evaluate expressions. Well, in order to evaluate expressions. So if something is written with fractions as an exponent, we want to convert it to radicals. Radical just means square root or cube root for us. So if there's a square root, there's technically an invisible 2 here, which means two things multiplied by itself can come out of the radical. You guys worked with radicals before last year a little bit, like square roots. By radicals, I mean square roots. You work with square roots and maybe a little bit cube roots. So the cube root of 27 is 3 because 3 times 3 times 3 is 27. So that's all we're doing. You could also have fourth roots and fifth roots, and when you get to algebra 2, you'll learn a lot more about rational radicals and rational functions. So did you say 7? Square root of 49 is 7. The square root of 121 is 11. 2 to the negative 5th. How do we deal with that? What do you do with the negative exponent? You flip it, right? So you would do 1 over 2 to the positive 5th, which is 1 over 32. And 13 squared is 169. You know what 15 squared is? 225. Some other common ones are 12 squared. You'll do that later. 14 squared. But anytime you will need something squared, you'll have a table for that, or you could always just work it out with long multiplication. So anyways, you can write a square root of a number using this symbol right here. That's a radical symbol. For any non-negative number a, the square root of a can also be written as a to the 1/2. Because there is, like I said, there's an invisible 2 here under the radical. So when you have a fraction for an exponent, I'll give you another example. So the square root or the cube root of a, can you guess how that would be written? A to the what power? Zachary, what'd you say?
Something. I made a guess.
What was your guess?
3 1/2.
1/3. So important, the denominator, so the 3 is going to determine the root. So if there's a 2 in the denominator, it'll be the square root. So 2 means square root. The number in the denominator. Is that what I said? I don't know if I said numerator on accident. The number in the numerator represents the power, or I should say the exponent. Because it's not always going to be 1. Sometimes it'll be 2/3, which means 2 will be the exponent. Sometimes it'll be 3/2, so 3 will be the exponent. Sometimes it'll be 5, so 5 will be the exponent, so something to the 5th power. So we're going to practice converting from fractions as exponents and to radical so that we can evaluate. Where did the... Uh-oh. Looks like one of my slides went away. Kapoof. That's all right. So 16 to the 1/2 power. So if you just see 1/2, that means square root. If you just see 1/3, that means cube root. So we would rewrite this as the square root of 16. And the square root of 16 is 4. make sure you write the step in the middle, because in the Edulastic assignment, it's going to have you do exactly this. It's going to have you rewrite it as a radical expression and then evaluate for the next step. All right. Part B says 25, and this is beside it, not underneath it, but I'm just going to write underneath. 25 to the negative 1/2. So first of all, you want to take care of your negative exponent. Negative exponent means flip it around. So we'll do 1 over 25 to the 1/2, positive 1/2. And then 25 to the 1/2 means square root of 25. So this would be 1 over the square root of 25, which is 1/5, because the square root of 25 is 5. So this would be written, this would be what it is in radical form, and this would be evaluated. The step before that is just getting rid of the negative exponent, because you can't have negative exponents. Okay, let's try part C. So 9 to the 5/2. So what are we going to do if there is a number in the numerator other than 1? So we're going to take the 5, and this first step is to put parentheses. So make some set of parentheses. The 5 goes to the exponent. So we're going to put the 5 outside of the parentheses. The 2 means square root. So this means the square root of 9 to the 5th power. So I'm going to put the square root of 9 here. All right? I mean, square root of 9 to the 5th power. Now, it's important to write it like this in Edulastic, or else it's going to mark it wrong. All right? So don't try to look up how to do this from a different website, because it's going to tell you that there are other ways you can write it. Technically, you can write it as square root of 9 and then put the 5 on the inside. Technically, you don't need the parentheses, but I want you to write it like this when you type it into Edulastic. That way, we're all on the same page. And this helps you evaluate it easier. So to evaluate this then, so this is in radical form. In order to evaluate, I'm going to simplify the square root of 9 first. So what's the square root of 9? 3. And then I would do 3 to the 5th power. Well, I don't know what 3 to the 5th power is off the top of my head. We're still not using a calculator. So how do we figure it out? Well, this 3 to the 5th power is the same thing as 3 to the 3rd power times 3 to the 2nd power, which would be 3 to the 3rd power is 27, 3 to the 2nd power is 9, and then we would figure out 27 times 9. Would I expect you to do this on the quiz? No. I would give you an easier number to work with, but we have this, so we're going to do it. So let's figure this out. 9 times 7 is 63. 9 times 2 is 18. Plus 4. Plus 6 is 24. So 243 would be your final answer. Any objections? Okay. Let's do the last one on here. Oh, that says C twice. Oops. It's supposed to say D. So 4 to the negative 3/2. First step is we flip it. So we make it positive. 1 over 4 to the positive 3/2. Then we still keep this part under 1, and we're going to do what we did above. We're going to make parentheses. What's going to be our exponent now? 3. And then since it's a 2, that means square root of 4. So this is radical form. Next, let's evaluate. So I take what's in the parentheses. The square root of 4 is 2. And 2 cubed is 8. So this would be 1/8. Got it? Now do the you try questions. Oh, can you change number 1 to 144, not 49, because we kind of already did 49 above. So I'll give you a couple minutes to try. Jack is wearing the perfect sweatshirt for this lesson. How timely. Roots. Like square roots and cube roots. He knew that we were going to learn about square roots today. $144, not 44. Yeah, you guys, it's $144. And 144 is a perfect cube, or perfect square. Remember, 1/2 just means square root. Only when it's not 1, that means you have to raise it to a power. So if you're thinking ahead, you can think, okay, I got to take the square root of that number, and then I have to cube it, or then I have to squeeze to the 7th power. And if the exponent is negative, then you know it's going to be a fraction. So like number 2 is supposed to be a fraction. Number 4 is supposed to be a fraction. All right. So for 1, you're just doing the square root of 144, which is 12. Number 2, I have to do 1 over 36 to the 1/2, which is 1 over the square root of 36. The square root of 36 is 6, so 1/6. Did you put 6? What do you put 6? Should be 1/6. Number 3, so I'm doing the square root of 25 to the 3rd power. The square root of 25 is 5, so 5 cubed is 125. And it's on that poster too. So if you look 1, 2, 3, 4, 5, all that goes all the way up to 10. And then for 4, it would be 1 over the square root of 4 to the 7th power, and that would be 1 over 2 to the 7th power. Here's a way to think about it. If you know 2 to the 6th power, so 2 to the 6 is 64, so then you just do 64 times 2 again, which is 128. So 1 over 128. Okay, fix anything you got wrong, and then flip your page over when you're ready to do the next. So we just did cube roots. Guess what the next page is? Or no, we just did square roots. Okay. The next page is cube roots. So if b to the 3rd power equals a, then b is the cubed root of a. So cubed root goes in the blank. For example, 2 to the 3rd is 8, so 2 is the cube root of 8. The cube root of 8 can be written as cube root of a. So with the square root symbol, but there's a 3 there, which means it's the cubed root, which can also be written as a to the 1/3, which is like what we just talked about. So here are examples. Number or part A. So 27 to the 1/3. So if it's just 1/3, that means simply cube root of 27. And just to reiterate, if you're doing the cube root, you have to write the 3 there to signify that you're doing the cube root. In Edulastic, it'll give you like a little box, or you'll see the difference between the square root and the cube root option with Edulastic. So the cube root of 27 is 3. That's one of your perfect cubes. I'll only be asking you your perfect cubes. B, since it's negative exponent, we'll do 1 over 8 to the 1/3 first, or you can just write it straight as 1 over the cube root of 8. The cube root of 8 is 2, so 1/2. You might be wondering, how can something that looks so complicated end up being so simple? That's math. Okay, C and D is where it starts getting a little tricky because now we have a numerator. So here, just remember, the 4 means it's to the power of 4. So the easiest way is to just set up parentheses, put the 4 there, and then take the root of whatever the denominator is. So the cube root of 64. So the 3 means cubed root of 64. Look up at the poster. Cube root of 64 is on there. It's 4. And then 4 to the 4th power, you would have to do 4 times 4 times 4 times 4, which is like doing 16 times 4 or 64 times 4. And I'll save you some mental math. It's 256. And then D, we're going to have a fraction again since it's a negative exponent. So 1 over 125 to the 2/3. So 2 is your exponent, 3 is your root. So I'm going to put 2 in the exponent, and then the cube root of 125. And this should make sense because 25 is a perfect cube. So we wouldn't put a number under there that's not a perfect cube until you get to algebra 2. So the cube root of 25 is 5. And then you're squaring 5 again, so it's 1 over 25. Any questions so far? Okay, I will let you try the next ones. Convert it to radical form, then simplify. And remember that if it has a negative exponent, it is going to be a fraction. I'll give you 2 minutes. And if you're done, you can check your work with the neighbor. How about if I check you, I can open up your homework and you can get started on that. Check your answer with the neighbor first and then raise your hand to get checked.